Talking about resource recovery from wastewater, how is it possible to choose the correct anaerobic digestion technology?
I would say that in order to choose the best anaerobic technology to treat an industrial effluent from wastewater, you need to consider the characteristic of the wastewater itself. So the first step is to have a sampling campaign and to take different samples of your wastewater to measure different parameters such as CO2, TSS, nitrogen, phosphorus content. And then you need to see what are your objectives. Are you interested in reusing the wastewater in your factory? Or are you interested in just making biogas in order to generate revenues and using the biogas in your industry? And do you have much space available? Do you have space requirements in your factory? Depending on those factors, you can have a look at the different technologies that exist and then select which one or which combination of technology would be the best to meet the discharge requirements that you need to meet before discharging your wastewater into the sewer or into a natural environment, for example.
And what are the best technologies available on the market?
So I would say that you have two main types of technologies regarding anaerobic treatment. You have granular sludge technologies, which are basically technologies where you have those granules, which are a mix of acidogens and methanogen bacteria, which are degrading the COD to form biogas. And those granules look a bit like caviar, and the goal is to keep them into a reactor. So we have reactors with settlers on top, different technologies such as UASB or EGSB. Biobed or bioethane USB, for example. And the goal is to keep the bacteria inside to degrade the COD. But those systems allow to reach very high volumetric loading rate. Therefore, you have a compact installation. It has a small footprint to treat a high COD load. But the disadvantage is that the quality of the effluent is maybe not as good, and then you need a post-treatment in order to meet discharge requirements. Those type of process are not good for water that has a lot of suspended solids or fat, oil, and grease, because they're disturbing the process and the granulation cannot be done as easily. So the other type of process are flocculant sludge technologies, such as CSTR, digesters, and those type of process are really suitable when your wastewater contains lots of solids or lots of fat, oil, and grease. So we're looking basically at regular CSTR, which we call biobulk, which is a combination of completely stirred tank reactor, and you can have an anaerobic settler next to it if you need to retain your biomass in your system. But we also developed more recently a new concept, which is an anaerobic membrane bioreactor. Our system is using ultrafiltration membranes. And there, the main improvement is that your effluent quality is very good, similar to to an aerobic effluent. For example, we usually reach below 100 milligrams of COD per liter in our wastewater effluent in the end, in only one step in the anaerobic digestion step. So depending, I would say one of the main factors is the COD concentration and the TSS content of your wastewater. So looking at those parameters, you can choose. If you have a higher COD, higher TSS, you will go for a flocculant technology, while if you have a water with mostly soluble COD and lower TSS, you can have a look into more compact and granular sludge technology, such as EGSB or USB.
Are there some key examples?
Yeah, well, very recently we're now starting up a new plant in South Africa. It's treating dairy wastewater from woodlands, so it's a dairy factory which produces milk and cheese. So the wastewater is mainly processed wastewater, but also whey. So this mix of wastewater is treating into a membrane reactor, our anaerobic membrane bioreactor. And then the effluent, the permeate of the UF membrane, goes directly to a reverse osmosis unit. And what is very novel of this process is that in only 2 steps, membrane plus reverse osmosis, you can reach a sufficient water quality in order to directly reuse your water into your factory, into the process. So in this case, we have no aerobic step, which is pretty new, because usually anaerobic technologies are combined with aerobic technologies to meet discharge requirements. But in this case, we only do it in 2 steps without aerobic ways. So that's a successful story.